This is a Neurode headband. It is a wearable that treats and tracks ADHD in 20 minutes a day from home without drugs and without side effects. The way it actually works is we're sending in a high frequency current that boosts brain activity. Because there's this core principle in neuroscience, cells that fire together wire together. Next time when you go to do a task with or without Neurode, those neurons get activated more easily. A lot of companies in neuroscience are looking at how do we have more channels, bigger, which ends up being more like MRI. But through my work, I realized our models were great, but they weren't being used and being translated clinically because it was so expensive, so time consuming, and we actually just needed more data. One of our goals is to build the world's largest brain data set. While people are using the headband, we're also obviously measuring the brain so that we can personalize that treatment, but at the same time, we can build a better understanding of the brain. It's incredible and insane that we have rockets going to Mars, but we don't understand how our brains work.
Let's just start off with the elephant in the room question. What are we wearing and what do they do?
Yeah, what are these things in our head? This is a Neurode headband. It is a wearable that treats and tracks ADHD in 20 minutes a day from home without drugs and without side effects. But at its core, it's a combination of brain imaging and neuromodulation or brain stimulation tech designed to improve focus, memory, impulsivity. But this core tech can be used to read and write from the brain in a number of different ways.
That's reading right from the brain sounds so crazy. I love it. So it's basically my understanding is that there's kind of two core pieces of functionality. Piece number one is reading. So like being able to know like levels of brain activity. And is it literally just levels, like, more or less, or does it get pretty granular in terms of the amount that you can know what's going on?
Yeah, so we talk about it in like changes in brain activity levels, but what it actually is 152 channels measuring changes in blood oxygenation. And so this technology is called functional near-infrared spectroscopy, or FNIRS for short. And it's shining two different wavelengths of near-infrared light into your brain and looking at how they're differentially absorbed by oxygenated and deoxygenated blood. So you might be familiar with like oximetry, works similarly.
Like on your finger.
On your
like
finger,
the thing,
how the Apple Watch is reading things, or your Aura, if you ever take it off and see the lights inside. Those are green lights. We're using red. They travel further. And so it's much more similar to an MRI, looking at changes in oxygenation, and that tells us about brain activity because essentially it tells us about how your brain is distributing resources.
Okay, so it's shining two different wavelengths of light, and then they're being absorbed differently. So if there's oxygen, then it like gets reflected more or something, and then if there's no oxygen, it just like goes right through. Is that basically?
Well, one wavelength of light will respond in one way to oxygenated and deoxygenated blood, and the other wavelength will respond differently as well. And so what you do is you're saying like, oh, how is oxygenated blood changing in terms of reflection and absorption of light, and how is deoxygenated at the same time? And so it's like these relative changes.
Okay, cool. And so so that's the measurement side.
That's
And
the
then the
measurement
actual
side.
stimulation or like doing things side is like electrical pulses, literally.
Yeah. So our brains are electrochemical, which means you can interface with them and modulate them or change them either electrically or chemically. And so traditional pharma or medication and drugs that we're used to, they influence your brain chemically, but they often have side effects. And that comes from what we call off-target effects, which is basically the way that those chemicals interact, not just in the area you want them to interact, but all throughout your brain and body. And the benefit...
Because it's a blunt object, right? It's like
Well, it's a blunt tool,
when
exactly.
you're chemically just soaking your brain in new chemicals, it just goes the whole. There's no way to make it just go to your prefrontal cortex or something. Yeah.
Exactly right. And so the cool thing about electrical signals is they can be far more targeted. And with ADHD or with focus, the area of your brain responsible for focus, memory, impulse control, decision making, a whole bunch of different things, planning, organization, that's in your prefrontal cortex here. And so if you wear a headband right across there and then stimulate that area in a more targeted way, you can bypass a lot of the side effects and really activate the areas that you care about and modulate those. And then when you combine the stimulation with the monitoring, I think things get really interesting because it's incredible and insane that we have rockets going to Mars and things like that, but we don't understand how our brains work, which is the thing that influences everything we do, everything we experience, everything we create, like we feel, everything. To unlock an understanding of our brain through brain monitoring would allow us to do like a huge amount of things, one of which is have far better therapeutics. So far better, fewer side effects, more effective ways to change our brain when it comes to mental health or well-being or brain-based conditions. And then like one day also just what else could an understanding of our brain unlock in terms of like, wouldn't it be great? Doesn't everybody want to focus more and
Yeah.
things like that?
To that point specifically, is this something that exists in a lab, but it's like a big, gigantic thing that's like costs hundreds of thousands of dollars, and like, yes, you could do it, but it's just cost prohibitive, and that you've made it cheaper? Or is this like a new type of thing that I wouldn't be able to find in like a brain neuroscience lab?
I want to say both
Okay.
because the story of Neurode does come from us, like me and my co-founder, Damien. He's an electrical engineer and physicist. I have a neuroscience background. We did meet at university. We started building all different types of tech for fun. And we ended up in the same post-grad research lab doing implantable brain-machine interfaces. So like a sort of Neuralink competitor, which was amazing. But then through that work, got to learn about like the fundamentals of measuring and modulating the brain in a very like granular level, and then realized the problems we cared about were non-invasive, which is, you know, this kind of technology. But from there, I went to work at a bionics company where we were using this $500,000, bigger than a fridge brain imaging device. And my role there was to build predictive models of neuroplasticity, so how the brain learns and changes, because this is implicated in a whole bunch of conditions. So the specific case was like, how do we know before you do a surgery, an optical, a cochlear implant surgery, whether your brain's going to respond, and be able to interpret the electrical signals from the implant as meaningful sound. And through that, like, I got to sort of form a maybe divergent like hypothesis of the space where a lot of neuroscientists and a lot of the companies in neuroscience that are neuroscience based are looking at how do we have more channels, bigger, which ends up being more like MRI.
Sure.
And that's like very valuable for research. But through my work, I realized our models were great, but they weren't being used and being translated clinically because it was so expensive, so time consuming. And we actually just needed more data. And we get more data by making it easier to use in the real world. And so my co-founder and I started by, first off, I called him and I was like, why are they so big and expensive? Like, there must be a physics thing. You're the physics guy.
Yeah.
Like, tell me why. And he thought about it and researched it and came back to me like 2 weeks later and was like, I've been banging my head against this problem to try and like find a reason why it can't be. And I can't find a good enough reason. Like, let's work on this. And I was like, hell yeah.
Let's go.
So we started, and we hadn't worked together since university. So it was really fun. And we're like, let's do another project. And so we started working on it and we were able to, 100x cost and size reduce the core technology, the FNIRS, with no loss in data quality. And so there is that component, which is a cost and size reduction, as you mentioned. But there's something emergent that comes out of being able to measure your brain in the real world. So traditionally, whether with MRI or in clinics or anywhere else, you only measure the brain when there's a real problem,
Right.
and you might do so once a year because it's so expensive again.
And you're in a weird environment, and you're like, you have to go down to the
Exactly.
basement of some dark lab or thing. Yeah.
Can't move. It's like all gray. It's dark or whatever the situation is. So it's not naturalistic, and we don't get daily measurements. And so when you're able to generate a daily brain data set where we can actually start to understand the natural variance in the brain, naturalistic environments day on day and day, you can generate data sets that are really valuable and help us understand more about the brain. And the emergent property from that is you can also use it to personalize treatments. And so while the core FNIRS already existed, and in fact, so did electrical stimulation, what comes out of combining them is that you can personalize the dose. And that's something that hasn't been done before. So with the data, we have these machine learning models that can track your focus, tell you how focused you are. And when you can measure focus in real time, you can then predict it. And on top of that, personalized dose. So the amount of stimulation that's going to cause the best improvement for you.
Very cool.
Yeah.
I feel like one thing, while we still have these on, I do want to ask the question about sort of form factor. So I'm sure you all thought about this of, do you put it in headphones or something, or do you, I think yours had to be across the front of the head because you're doing prefrontal cortex, but still, there are lots of different form factors you could choose. Yours is like, it's not hidden, like it's obvious that we're wearing this thing. And so I don't think I would wear it like every day, all day, but like if it's 20 minutes a day, which is what I understand you should do, then sure, why not? I'll just put it on while I'm like reading at night or something.
Yeah, exactly. I do it like I start my day, open my computer, put my headset on, do a 20-minute session. And it really helps me get looked in. But you know what? I think we should make them cool. I think they look cool.
They are pretty futuristic.
We're going to get some cool people to wear it, and then next minute it's a trend.
The real reason I really wanted to like ask about the form factor is more just about like, because I know that there have been other attempts at this, right? Like there have been other people that have made helmets or things that you can put on for a little while, or like little straps or headphones or whatever. So like,
why did we choose this?
Yeah, why'd you choose this form factor? Yeah.
Yeah, so there were a number of constraints, as there always are with like engineering and design, because because of we use FNIRS rather than EEG. Like EEG is usually where you can see the headphones. Um, with FNIRS, one of the great things about it is that it's highly spatially localized, so we can get like a a spatial resolution of less than a centimeter. So we can see this like beautiful map of your brain that is really detailed. But that also means that we need to have many channels at each of these spots to actually map that prefrontal cortex. So we had to have these channels across the actual space. And then we wanted it to be one size fits all, which is why we have this. Some
Oh, the
people
vertical
say,
thing?
yeah, some people call it like a
Mm.
picket fence. Some
Yeah.
people say like a spine. But you'll notice, and I'll take mine off now to show you this,
Yeah.
it's very flexible.
Mhm.
So that means it can fit like different head sizes,
Mm.
and that allows us to do a one size fits all. Um,
My large
and
head,
yeah,
included in that.
and we probably all have a couple of marks now. So I'll turn it on for you later, and you'll see all the lights shining
Oh,
through
sure.
there.
Cool.
Um, so yeah, fit everybody, and we wanted good contact between the skin. And what was actually a challenge is getting something that bends this way, but
Mm.
then also can bend this way.
Yeah, yeah.
Because usually when something bends this way, it flares out,
Sure.
um, and vice versa.
Maybe let's break it down into like measurement and then
Cool.
stimulation. So on the measurement side, the FNIRS sensors, I've heard about FNIRS, like it is the pulse oximeter thing. Like, so is there, you said that you made them much smaller though. So can you talk about the challenges of making a small FNIRS sensor that fits in something like this?
Yeah, so it's interestingly like it's not the sensor itself that's small. It's getting many sensors
Mm.
condensed in a small headband, and having the processing and everything be small,
Mm.
because usually they run with lasers on a like it's on like a big processing unit.
Mm.
And so if you've seen like a big FNIRS, that's what's happening. And so really it was about changing it to LEDs, making sure we're still getting the same data quality, like how we
Mm.
are getting, what kind of digital signal processing are we doing that's going to maximize that signal?
Mm.
How are we, and like another benefit is that we're only doing the prefrontal cortex.
Yeah.
Some headsets do the entire head. And
Mm.
so we made a decision early on the brain area that we cared most about. And that really helped us as well, like refine the problem space. So PFC, we think, is like one of the most interesting brain areas. It's responsible for so many of your higher order functions. And I think that's where we get the most leverage. Like in terms of like the delta of being like where I am now and what I would like to improve and the things that we care about improving. Like obviously the back, we're like vision, obviously cool to improve your vision, but like that's just not how it works. And so, it's the area that there's like so much space to improve.
That is cool. So you specifically have chosen to focus on the prefrontal cortex because of the use case of ADHD, or there are other things also that you want to do
There are
there?
other things also. So prefrontal cortex, as I mentioned, yes, focus, memory, impulse control, which is ADHD, but memory is implicated in age-related cognitive decline, which is something we care about. It's also like affected in anxiety. So areas of the prefrontal cortex play a role in anxiety, depression, ADHD, but also things like planning, decision making, um, a lot of your higher order it's the home of executive function. We want to start with ADHD and really focus there and potentially expand to other conditions that I mentioned, anxiety, depression, age-related cognitive decline. But then also, if we want to look at like how does neurotech play out like 10, 20 years from now, well, maybe everybody's enhancing their performance. And the areas that we're going to want to enhance are these things that
Mm.
make
That's
humans really
smart.
smart. And how do we make ourselves even smarter and more effective?
That's smart. That's cool.
Yeah.
Because I think that I've heard about some sort of stimulation thing for like a memory or something like that. And I think there was some other company that I remember about like athletes or something. Do you know what I'm talking about? Where they were
Yes,
like,
Halo. It was like quite a
yeah,
while ago.
yeah. It was like,
Yeah.
and they like, it was something. There was some demo of like you could balance on one of the boards better or whatever if you like wore this thing for a little while. Like what happened to those other ones?
My understanding with Halo was that it did actually work. Like the founders are pretty incredible. They did a lot of scientific research, but maybe sports improvement wasn't the right first use case. Because if we think about like a completely novel like way of interacting with technology in our brain, like we there are no brain neurotechnology or brain interfacing machines that we use daily, or even not daily, really. And so there isn't a huge concept for how that would make sense in our everyday life. And so it's really important the problem you choose to solve with that, where the pain point is big enough, the improvement is big enough, that it starts to make sense, and that like there's a narrative that people who are using it can really understand as to the value of it. And so I think, or like my take on it is at least that potentially like athletes getting small performance or like small to medium performance improvements maybe wasn't the right first use case. So I think that was a tough one. Yeah.
Fair enough. I mean,
Yeah.
I think that in my recollection of why they chose to do that was that it was a cost thing. It was like they could make something that was roughly similar. I'm sure that it had different sensors and different
Yeah.
stuff, but
Very
I mean,
different.
like the basic idea was like some sort of wearable that improves your performance, and it was just so expensive that it was like, okay, well, if we have to focus on somebody, it has to be the very top end of the market that can afford
Mm,
$10,000 or something for a wearable. Like, who else
yeah.
cares that much about enhancing their brain activity? And so I
Yeah.
assume that trying to keep this thing cheap is a huge consideration if you want people to wear them just like people. Uh,
Yeah, it's definitely a consideration. But the other people who want to spend money on changing their brain are people who are like are really struggling with whether it be ADHD or some other health issue. And so I think there's like another way of that. It's like, okay, who, is trying to be very high performance, like athletes, and that probably have some money, or who has a really big problem and is used to spending a lot of money. Like ADHD medication's kind of pretty expensive. Not all of them, but like the third most prescribed ADHD medication called Vyvanse, it's like $400 a month. It's crazy. And there's no generic yet. Oh, well, they just came out with a generic about a month or two ago. Um, but for the last 20 years, it's been $400 a month. So people are already spending money on their mental health. And so if we can be cheaper than that and help them and not have side effects, like I think that's the use case. But you're right. It it is like there is a cost. But I think as well, the difference between, let's say, a sports use case is like currently your sports costs are maybe your gym membership, your supplements, things that you need to keep spending money on, and then you're adding this, and it's for like an enhancement on where you're already going, which is the end goal of neurotechnology, I believe. But uh, with Neurode, it might be, okay, medication doesn't work for me. I don't want to deal with side effects. I don't want to compromise between symptoms, like trying to focus and struggling with these things, and side effects, like I can't sleep, I can't eat. And so when you're stuck in that place, you're actually swapping it out. You're saying, I don't want to take meds or I can't take meds. But I still have this problem. So there's like a gap I need to fill. And so you're swapping out, let's say, medication spend for
sure.
Neurode,
Yeah.
in which case the price is much more comparable.
That makes a lot of sense. I
Yeah.
mean, so you've said a couple times now, like zero side effects, which like, I don't know, just skeptic, like
Yeah.
natural
Yeah.
skeptic that I am. It's like, how could you know that they're literally zero? I mean,
Hmm.
and that's like a big claim for like a sort of like medical adjacent or directly medical company to
Hmm.
make. I mean, so let's go to the stimulation side then, because I
Yeah.
think that's the more
Yeah. Let's
relevant,
do it.
like, thing that's happening to your brain that could be scary. I don't
Mhm.
know. So yeah, can you tell us more just about the specifics of like how many amps are we talking about here? Like, is
Mhm.
it like volts or like what's the actual like electricity that's going through my brain,
Mhm.
and how do we know it's not going to like fry
Yeah.
me? You know what I
Yeah,
mean?
yeah, yeah, for sure. Um, so I'll touch on a couple things. One, well, like I can't say our exact dose because we're still
Fair. That's
patenting
that's
like
fine.
our stuff,
That's
but
fine.
like essentially there is a safe limit on stimulation, which is 4 milliamps.
4 milliamps.
Yeah.
Okay.
And so we're not in even in amps.
Hmm.
While we are not FDA approved, we'd love to be and we're working towards it. But there is a limit and it's hardware limited. So like our headset cannot go above the safe limit. In fact, it can't even go above 3 milliamps. So we're like well below. So this technology, I guess, has been around for a while. It's been demonstrated like safe, and the FDA consider it non-significant risk, which means like nothing too bad can happen. Um, in a sense, it's speaking your brain's natural language, which is electricity, or electrical signals. And so um, the way it actually works for Neurode is we're sending in a high frequency current that boosts brain activity. And how it does that is essentially your neurons are sitting at like their baseline. And when they go and get activated, they need to reach like a threshold. And that threshold, if it passes it, an action potential occurs. If it doesn't, nothing happens. It's like a light switch on or off. And so when you have ADHD, you actually, when you're trying to focus, we look at your brain activity, your neurons are less active. They are activating, but not to the same degree as a person who doesn't have ADHD. And that's because focus requires more energy to execute well. It's like much harder to focus deeply than it is to like get distracted by every little thing. And so the goal here is to boost brain activity, specifically in the PFC while someone's trying to focus, to improve or to increase the number of neural resources that person is dedicating to focus. And so we're giving them a hand with that. And so the high frequency or noise stimulation actually works by stochastic resonance. So we're increasing the baseline so we're not actually forcing neuronal activity to occur that wasn't going to occur. We're making it easier for the neural activity that like those neurons that may not have reached action potentials to actually get across the line. I'm going to boost them. And so the amount of internal energy that your brain needs to produce to activate those areas is lower. And so we can activate more of them more easily. And so I think that makes it a little safer because we're not forcing neuronal activity that wasn't going to happen. You're not going to get these like weird stuff happening. It's like things that you were going to, neurons that were going to try and activate anyway are just activating more easily as you focus.
Interesting. So it's like basically, if I could think about it, like 0 to 1 is like 1 is the trigger. Like once I get over that, an action potential fires, electrical
Correct.
activity zooms down the axon. I'm like
Yes.
pulling from my
No,
high
you're doing
school
well.
psychology. Let's
Yeah.
go. And so basically, you're taking it instead of having to go all the way from 0 to 1, which is maybe hard if I have ADHD and I'm depleted of energy or something. You're making it so that, okay, our baseline is now 0.5. Like I'm just going to stimulate it up to 0.5, and then you only have to go half of the way for the whole activity to happen.
Exactly.
Wow, interesting.
Yeah, exactly.
That's super cool. Okay.
So it just makes it easier. And then in terms of side effects, I will say like almost nothing has no side effects. Even coffee can like you have too much, makes you kind of anxious. And so what we're saying when we say no side effects is that like in clinical trials, for example, when we give people stimulation and fake stimulation, which we call sham, or is otherwise known as placebo, like the same headset, it turns on and ramps back off again. So you get the same tingle and then it's gone. We see no difference between those groups in the reporting of side effects, which means is the side effect it's indistinguishable and impossible to tell if the side effect is due from stimulation or just from placebo. And those are things like obviously tingling. I don't know if that's a side effect. I think it's just a fact of stimulation. Like it has a tingle sensation. Not every time, but sometimes. And then some people say like, oh, you do see a little redness under the electrode. That's from increased blood flow, which again, I view as more like a fact of
Right.
stimulation
Yeah.
rather than a side
Sure.
effect. Like it's
Yeah.
going to happen,
Right.
like 100%. So
Yeah.
potential side effects are things like headache, fatigue, things like that. But again, it's hard to tell because when we do placebo versus real, there's no difference in reporting of those things. And so it's impossible to tell, like, did I just get a headache because we're people and we get headaches, or did the stimulation cause that headache? But either way, far milder in severity than, let's say, things like existing treatments for ADHD. Like the amphetamine-based treatments have pretty serious side effects that are like, at least for me, like I have ADHD, diagnosed when I was 5, tried so many different meds, tried all these different like random doctors doing like the strangest things. Like my parents, when I was a kid, sent me to someone where I would like go there for an hour and follow a ball on a string, like
Like
trying to,
hypnosis or something.
and it was like trying to train my eyes. They were like, oh, no,
Oh,
no, 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 you
interesting.
have an eye problem. It's like, pretty sure I have
No.
ADHD. Or like it was a way for them to treat ADHD, like some kind of like strange, obscure doctors because I couldn't take medication. There were so few science-based alternatives for me. And so as a neuroscientist with ADHD, I wanted to create or we wanted our team to create a science-backed alternative that wasn't like some goofy eye tracking thing.
So you hinted at, or maybe you like, I don't know if you can say, but you have done trials on this, and
Yeah.
what have those trials shown?
So we've done a placebo-controlled double-blind clinical trial, and I can't share results yet because they're going to publish them, and so they'll be available for
Exciting.
everyone to see, which is very
How
exciting.
soon? Do you
Um,
know?
I don't know how
Okay.
soon. Basically, the process is we're gonna, file our patents,
Cool.
and then we can publish it for
Okay.
everyone to
Blink
see.
once if it worked. Blink twice if it didn't work.
Well, obviously, I can say, like, obviously the results were exciting for us because following the clinical trials, obviously we're now publishing them. And then after that, we launched our private beta where people could actually try the device. And what I can share more about is the private beta results because those are like already out. It's like real people. There's nothing we can do. But yeah, 85% of our cohort saw pretty meaningful improvements in the first month of using Neurode, which is really great to their ADHD. And something I should explain about how Neurode works is medication is something where it's like an instant huge improvement. If it works for you, which it doesn't for everyone, but if it does, you have this, and then you kind of crash, and then you take it again the next day, and you're doing this zigzag situation with Neurode because we're working electrically and increasing the likelihood of firing of those neurons. We're actually promoting neuroplasticity. So it's a long-lasting improvement. So rather than having this big spike and then go down, it improves you, let's say, and I'm making these numbers up, but let's say 5% per day. And so you increase by 5%, but it compounds. And then the next day it's another 5 and another 5 and another 5. And so by the end of the month, you've reached a much greater improvement that is long lasting. And so what we see is like, even if you stop using Neurode for a week or a couple of days, the improvements that you received are long lasting. Not permanent, but like they will eventually go back down. But that's pretty exciting. And I think related to why the side effect profile is much milder is because we're not like yanking something all the way up and then crashing. But I think a good analogy for this is exercise. So like if you go to the gym trying to build muscle, you don't you don't walk out with abs your first day. You might sleep better, you might have like more energy and you see some like mild benefits, but the real benefit comes from repeated use or repeated exercise. And then at the end of like a month or 2 months, like you've built this muscle. And so in the same way, we're strengthening the connections between your prefrontal cortex neurons and allows them to get activated on their own more easily over time. Because there's this core principle in neuroscience called Hebbian law, and it's cells that fire together wire together, and it's the basis of neuroplasticity. And so because we're getting more neurons to fire together in synchronicity, as we said, because they're getting activated more easily, that's actually strengthening the connection between them. And so next time when you go to do a task with or without Neurode, those neurons are getting comfortable working as a team. And so next time you try and focus, they'll get activated more easily.
Yeah, I'm very curious to hear about like the total amount of current or whatever that's passing through your head when you're being stimulated. I mean, you
Mhm.
said it's like on the order of like low milliamps,
Yeah.
and then like low volts presumably. So like, can you just talk about like the normal activity in your brain and how it's different from that, or like what's happening?
Yeah. So a normal individual neuron is resting around minus 70 millivolts. And when it gets excited, it goes to about plus 30.
Okay.
And so we're dealing with the movement of ions like sodium and potassium in and out of the cell. So it's tiny, tiny amounts, but that's an individual neuron of which there are millions in like a square centimeter of your brain. And so we're looking at sending current through electrodes here, and that current spreads. Now, your skull is designed to protect your brain, so current does not easily go through. And this is exactly why monitoring is so important, because we want to be able to confirm that some of this current is getting through into your brain and that it's causing the desired effect. Because the default state is like most of it will not go through. And so it's about finding the right dose to cause the desired brain response in each individual. And that will vary based on skull thickness, distance between brain and skull, all of these anatomical differences. And so measuring is actually really important for efficacy. Um, but then, yeah, and then in terms of like how much current is actually getting through and causing a brain effect, um, it's actually like kind of impossible to measure. There are simulation software that allow you to simulate this, but we would have to actually put probes inside your brain to know how much current was actually getting through. Um, but yeah, it is shared across millions and millions of neurons, that
Wow.
current. Yeah.
Fascinating. Yeah, that is actually like the brilliance of having both the measurement and the stimulation the same thing. Because I imagine there's other differences between people. Like not everyone's brain's the same. I mean, broadly we know like this stuff goes here and that stuff goes there. Like I know that we have sort of very broad mappings, I'm sure, but I'm sure there's differences in terms of like even I mean there's probably even differences in terms of just like if you position this thing slightly off, like if it's here versus there, then like
Exactly.
you're gonna have to know like where how it's oriented in order to
Exactly.
stimulate the right places.
Exactly. That's why monitoring is so important. There's also a bunch of cool solutions that we have that allow us to do that. So when you put your headset on, there's these two little lights that come out on the front, and we help you position it the
Oh,
same way
cool.
every time. So
How does that work?
basically, when you put this on,
Yeah.
I'll just do it now. When I put this on, we have two little lights that come in these two,
Yeah.
and so that's and then the middle one is used as an aligner. That's off.
Oh,
So then
okay.
I just access my front camera. These are 2 lights on, and we tell you to place it
Oh,
like
got it.
this.
Okay.
Yeah.
You go look in a mirror or something and put it in the
Well,
right spot,
no,
or
we use a front camera on your phone.
oh, okay,
So
nice.
it's automatically, like, integrated into the app.
Oh, cool. Oh,
Yeah.
nice, nice.
So we
Oh,
can
so
get
you just go like this, and then it like
yeah,
tells you like move it a little
because the
bit.
main way to interact with the headband is with your app on your phone.
Yeah.
And so, like, you're already there. We just open the front camera and we're like, all right, just move it a little bit to the left. And we
Oh,
put a
sick.
line, like, we help you
Oh, very
get
cool.
that
Very
right.
cool.
Yeah.
And then okay, this is a totally separate topic. Going to take a wild shift, but I'm
Let's do
very
it.
curious to hear. Like, what are the? How did you decide on the levels of voltage, levels of like the amps that you're going to put through the thing, on the number of sensors? Like, how did you decide? Like, make all those engineering decisions? Because
Mhm.
so for something like this, like we build satellites. Like there, there's a lot of like modeling software because
Mhm.
it's kind of hard to put things in space and just like test it
Mhm.
randomly. And so in that way, it's actually kind of similar, right? Like it's hard to go actually access the real environment, which is
Mhm.
either putting stuff on someone's brain or like putting something in space. And so we rely a lot on like simulation. We rely on like different sorts of environments that are similar to that. Like we have vacuum chambers down the hall that you can like pull all the air out of, and then you can simulate like something in a similar environment to space. But I imagine that you guys had to make a lot of decisions with maybe not a lot of data, like real brain data to
Mhm.
decide all those things. So
Yeah.
how do you make those sort of engineering decisions?
I think it's a combination of research, simulations, best guesses, like intuition. Um, like me and Damien, my co-founder, we talk a lot about how you develop intuition for these like non-intuitive things. So he's a physicist and math, like pure math. He's like, and he just has this incredible intuition for understanding like physics and math and things that I had known very little about. A lot of this came from just like intuition, ended up playing out in clinical trials. Thank goodness. Right. Like, and so it started out being like, we, like actually a lot of first principles thinking. So like what would make most sense and what is the downside of trying it this way? And the like cost benefit analysis, like what is the downside of having as many channels as we can possibly fit in there? Obviously cost, but then like, well, is the data worth like the amount of data we're getting it like worth the cost? And then the other question is like, what is the fewest number of sensors we can have while still generating enough from like machine learning models that allow us to make the product really great for people? And like running these things and finding the like overlapping points of those things and then going, yeah, that feels right. And then obviously we did a lot of testing. And so while we don't have uh, access to like directly your brain and live people, what we can do is do things like, okay, well, we do have a $500,000 brain imaging device that is used in labs. Maybe we can compare the performance of our device to that on real people, and then make sure that like our data quality is like exactly the same as theirs. And that's how we like sort of benchmarked that we were able to that the cost and size reduction didn't come at a data quality loss. And so we can do things like that. Looking at a lot of literature, um, combining uh, different perspectives, like Damien's physics background, and looking at electrophysiology, thinking of an individual neuron, because we come from implantable devices, we are thinking of individual neurons, and then like going that kind of first principles out to clusters of neurons, and like, well, if we think about it this way, and then like, how does that track with the simulation software that we're seeing, which like hopefully is right, but like someone made that, so who knows? And yeah, and then obviously the gold standard clinical trials, like you make all these decisions, you hope that you've made good ones, and then you have to kind of have this moment that you invest in like this big expensive, um, you know, exciting clinical trial, and just like hope that your decisions play out. Um, and yeah, luckily so far, I mean, we've made plenty of wrong decisions, but we've gotten to a place where they're they're working out.
I love it. How many different R&D versions of this do you think you've gone through?
This version is 6.2,
Okay.
but there's like 1.12345
Sure. Yeah.
6 point, yeah, so 6.2. We're working on 7.0 next.
Exciting. So
Yeah,
what? Oh, how many years have y'all been around then?
4 years.
4 years. We're at like whatever 5 major or whatever. What did you say? 6.1. Sorry. What?
6.2.
6.2. So you've gone through 6 major revisions and you're making the seventh. Like what are the sorts of tools that exist or that you wish existed for this kind of thing, like the prototyping specifically?
I think the tools are pretty great. Like, I mean, we use Altium and other kinds of like and CAD software and like all those kinds of things. I think the hard thing is just like it would be actually amazing if you could prototype these things closer to you. So what we
Mhm.
are, and that would like And I'm sure you can, it's just very expensive to like build, I don't know, like like a full electronics pick and place type thing in your office.
Right.
But yeah, I think the thing that is most challenging is the iteration cycle time. So like we would love to be like 5x as fast, and like probably could be in terms of like engineering time, but then there's like ship it, wait, it comes back, oh no, there's a mistake. Uh, that's another 3 week, like 3, 4, 5 weeks, like order another set, test them. And I think one of the things we underestimated was like the amount of engineering that goes into the product. You assume you're like, obviously it's going to take work, but the amount of engineering that goes into the test, like building your test jigs and all the testing that allows you to benchmark your product against each additional version is the same amount of work all over again.
So I imagine that this sort of idea is sort of uniquely it's like it seems perfectly well suited for people to be really skeptical of it. If that no
Totally.
offense or whatever,
No,
but
no,
like
no, no,
I just
take
think
it.
like it's like a wearable, it's like your brain. People don't really know how brains work. It's like claiming this like very big thing, which is like they can prevent this like disease, the disease like or condition that a lot of people have and like really impacts people's lives. And so I don't know, like what sorts of things do you tell people, like a VC, that you walk into the first meeting with them? I'm sure like they're skeptical. How do
Totally.
you?
I think skepticism is very important and it's like a healthy, good thing. Um, and in fact, like I think it makes sense, especially given like the history of like neurotechnology, maybe not so much from an implantable um, standpoint, but very much for wearables. We kind of just have to rely on the data from our like clinical studies and the bench testing we've done, and also first principles thinking about like how the brain works and how you might interact with the brain. Like it fundamentally makes sense that you can interact with the brain electrically, given it works electrochemically, and things like that. And really, I think there's an education gap. Like not that VCs are like obviously very well educated, but maybe not on this specific problem. And so actually starting from like, hey, what is focus? Well, and how does it show up in ADHD? And like, I mean, to be clear, we're not curing ADHD. It's a genetic component. We're helping people manage their symptoms, but really, it's at its core, it's not even necessarily about ADHD itself. It's that these symptoms happen to be the main symptoms of ADHD, but it's really about improving focus, memory, and impulse control, which happen to be the three most impacted symptoms of ADHD. Um, but at its core, that's what it is. It's just improving our ability to do that. Um, and so I think it's really about education and starting from like the fundamental principles of how your brain works and how we can interact with it. And then also, uh, I think, I mean, we're one of the first headbands, if not the first, to combine the stimulation monitoring. So we're actually measuring the brain. So we can show you the difference of your brain before stimulation versus after stimulation. And if that isn't demonstrating that something is happening, then I don't know what to tell you. Like, it's just not for you. Yeah.
I mean, this is like it's like a shift, but it's also like it's a shift in that's new technology. You've built something cool, but it's also like a fundamental shift for the industry, I think, right? I mean, when I think about health and like the health industry, I think like pharma. Like I just
Hmm.
think what's the cool new stuff that's being developed, like drugs. There's cool new drug development, or there's like new vaccines or that kind of thing. But I don't think about wearables yet. I'm sure that you would like me to think about wearables and you would love for the industry to move that way. But do you think like, are we going to need like a different, like some shift to happen to the industry to make that happen? Or could the pharma companies like invest in this kind of thing too?
They could. I think it's quite fundamentally different. And so we think a lot about like, what if the next pharma company or what pharma companies might look like in the future would be making electric medicine instead of drugs, or they may still make drugs, and there might be a new industry of companies making electric medicine. Um, but something like that I really love that one of our users said to us was like, this isn't like just a device. This is us not having to compromise anymore and have to choose between symptoms and side effects. And I think that when we're looking at medication, there's no way to move. It's very difficult to move away from side effects. And we've been trying to do this in pharma for as long as drugs have been around. And so if this is a way for us to manage conditions with fewer, if any, side effects, then it seems to me like kind of a no-brainer that we would move towards something that removes sacrifice from people's lives, especially for chronic conditions, like something where you can't cure it. Like ADHD's got a genetic component. And so you're going to be living with this for the rest of your life. and medication has side effects, obviously for like sleep and diet, but also at some point you may not be able to take them because they affect your heart. And if you have any heart condition, as we do as we get older, you're not able to take them. And so there's just so many ways in which this can be impactful. Um, and yeah, I think like it is just such a fundamental shift from how we view things. And that's why I think, and this kind of like loops back to what we were talking before, like finding the right use case. And I think starting in healthcare where people are having like a big daily pain point, and that there aren't solutions, the existing solutions are not solving it and they kind of feel hopeless. And so being able to, like, while it's a very different solution from what they might be used to, I know at least for me, I was like, I'll try anything. And so and then to hear that, like, oh, I'm not going to get side effects and all these things, it's like, it feels like a no brainer, from like a patient perspective. And so I think that actually completely novel technologies, especially ones where it does feel kind of too good to be true and like, whoa, how does this even work? Like, as you were saying, um, finding the right use case where you're solving a real problem is like a great entry point or like a wedge for novel technology to become adopted. And then one segment of like the population or a group of people start to be like, oh, this makes sense. And it like doesn't seem so kind of crazy and out there. And then it's really helping me. And then that kind of snowballs into more and more people accepting this kind of technology. And then it can look at other different conditions and then ultimately, yeah, be for anyone.
Electric medicine sounds really badass. I have to say that's super fucking cool. But it's the opposite of chemical medicine. I mean,
Yeah.
in my
Or
mind,
electroceuticals.
yeah, there
Yeah, I know.
electroceuticals. Okay, we'll
Electroceuticals
work.
instead of
Oh,
pharmaceuticals.
ceuticals. Yeah,
Yeah, we can
we'll work
workshop
on that
this.
one. Yeah.
Yeah, yeah.
Electroceuticals. I mean, they're very different though. Like we talked about this a little bit
Mhm,
before, but I think it's worth like returning to
mhm,
of pharmaceuticals. It's just a blanket that's put over your whole head of your whole body. Like you have to
mhm,
ingest something and then hope that the stuff, and it will, but like hope it gets up in the right places of your brain.
mhm,
Versus you can be extremely targeted and you can just target that one specific point.
mhm.
Like what are other ways in which these things are different or the same, or do you think it'll be a change from pharmaceuticals to electroceuticals?
I think it depends on the condition. So we've mentioned focus, memory, impulse control. Um, these are core core symptoms or core functionalities of our brain that show up in many different places. So again, ADHD, anxiety, depression, but also show up daily, even regardless of whether or not you have a condition. So I think um, what's interesting in thinking about how we expand is, and this is how like the monitoring becomes really useful, is we don't understand all that much about how our brains work. And if we ask ourselves why, it's because we don't like we're limited by the tools with which we have to measure the brain, and that limits our ability to understand it. Once you understand something, you can influence it in a far more targeted way. And so, like we think about all the time, like okay, like one of our goals is to build the world's largest brain data set, because while people are using the headband to improve their focus, memory, and impulse control, we're also obviously measuring the brain so that we can personalize that treatment, but at the same time, we're measuring that brain so we can build a better understanding of the brain so that we can look at other therapeutics, which is where like our big vision to like our sort of plan to eventually look at other conditions comes from. But we also always ask ourselves, like, what does the world look like and what does it mean for humanity to actually understand our brain? So, how does that impact so many like different areas and different industries. So obviously like healthcare is an obvious one. Like, your day-to-day life and productivity is an obvious one as well. But I think that like how it influences relationships, like self-understanding, how it influences like engineering and physics, like, or science. It's the tool with which we use to observe everything. Um, I think it even has like an influence in like politics because it like underpins decision making and like the way that we like form our biases and beliefs, just like everything. And so, yeah, I love to like just spend time thinking about what does it look like for humanity to understand their brains and what does the like what kind of like next frontier of discovery does that unlock for us?
Hmm, that's awesome. I feel have you do you welcome or do you resist the comparisons to like Aura and Whoop and Levels and these other companies that are like either making rings or like implants or whatever to like measure the different like I don't even know what you call it, but like bio data.
Yeah. I like love like I'm such a nerd for brain and body data. Like I love the idea that we can measure all of these things and learn about ourselves. Like so much of our life is just like trying to understand and learn about ourselves, like through our like just general experience of life. But then also, why not like from through our body, through the like biosignals and metrics that we have. So yeah, I love it.
And that, but
Yeah.
as like a company, do you think that like you would is your goal as a company to end up like a consumer device manufacturer that like everybody in this entire building would own their own headband, or do you want to end up like a, I don't know, I mean, like another model would be like a treatment that, you know, it's just for the people that really need it, and then they use it for as long as they need it, and then they're good, they're better.
Yeah.
Like what sort of like, what does success look like, I guess, for you guys? Is there one of these in every house?
So I think about Neurode in like and the neurotech like industry in different acts over time. Maybe something like this starts as specifically helping ADHD. So you have a big problem and you want to solve it. And so and medication doesn't work for you for whatever reason. And so you use a headband like this. And initially that can be like accessed direct to consumer. So I self-identify, I have ADHD, I want to try this. Or and then we get to go through the FDA because we have real world outcomes data as long as clinical trial data, or as well as clinical trial data. Um, and then we're able to get covered by like employers and insurers because that's currently how medication for ADHD is covered, but also because Neurode can be like at least 50% cheaper than those meds from a healthcare, like a health economic standpoint. So there's like an incentive to employers, for example, or insurers to cover this because it'll help their employees or their members improve their productivity, improve their focus, and do so at a lower cost and also with less side effects. And the thing about health economics is like side effects are just add additional cost. So if your Adderall is helping you or like your ADHD meds are stopping you from sleeping, then you take a sleeping pill, additional cost. And then just like snowballs. And so it actually ends up being more cost effective. And then once we have, you know, this being the main treatment for ADHD, there might be another condition, another condition. And then we've sort of got a shift in the mindset and the way that we think about neurotechnology. Now it's an actual thing that people are using regularly. And then how does that like trickle down back again into being direct to consumer where people go, oh, I have the ability to like very safely and with very little downside modulate my brain for my anxiety, for my mood or depression, and it goes away from being these clinical terms like ADHD, anxiety, depression, and goes into things like, oh, I'm improving my focus, I'm improving my mood. And who doesn't want to do that in a really safe and low downside way? So I think it like starts kind of direct to consumer, goes through healthcare, like even as a healthcare use case, ends up being like part of the healthcare system and then trickles back down to consumer where everyone can access these things. And at that scale, I think costs can come down a lot.
What how long, how many more versions until we get one for like I don't know, mental superpowers? Like like you know, can this thing make me smarter in addition to making me better at focusing?
Yeah, I don't know. With the rate of technological advancement being exponential, hopefully pretty soon.
Nice, good. I'll look forward to it.
Yeah,
Um,
it is available. I mean, if you have ADHD or you struggle with focus, it is available via our private beta, which people can like access through our website. We have like limited cohorts that like open up periodically. But right now it is limited to people who struggle with focus, memory, and impulse control.
what how many of these total have you ever made?
Not that many because we're using prototyping techniques,
Yeah,
like a
maybe.
few hundred.
Okay. And you've
Um,
deployed a few hundred to people now, or
we're
maybe
shipping
100 or
our
something?
next batch of 120 at the end of this month.
Cool.
Yeah.
Super cool.
Yeah, so
Is it
we do it in batches because we're still using prototyping
okay?
techniques.
And how many, like, just for like to get a sense of the numbers, like the first clinical trial was how many devices in the first, like, you know, private
120.
beta? 120 for the first clinical trial, also 120 for the private beta thing that you
Yeah,
said,
so
the 85%? Yeah.
uh no, I can't share the number of our
Oh, okay,
first
that's
beta, but
fine.
our next beta will be 120.
Okay, cool. Very
Yeah,
cool.
yeah.
That's awesome.
Clinical trial 120. The next set of the next beta cohort will also be 120.
Very cool.
Yeah,
Well, I'm
very
excited to see
exciting.
those results. I think
Thank
you
you.
guys must be excited to have it out in the
Can't
world
wait.
too. Oh
So
my
it's
gosh.
actually so rewarding because we've spent 3.5 years in R&D from like hardware, software, all of this engineering development, clinical trials. So so much like deep work on this without actually being able to interact with like our main users. And so now being able to like have it out in the real world, be receiving feedback, being hearing from users how they're benefiting, them posting it online is so cool as
Yeah.
well. And just like, yeah, super rewarding to see that we're
Locked
able
in.
to
Like,
help them. Yeah, so much locked in content online. But that's like the best part because like we're actually able to see the impact that this can have like immediately on people. And that's like why we do it.
well, no, thank you so much for doing this. This was awesome. If you have one ask for the audience, if you want to get people to sign up on the website, or are you recruiting, or want some
Yeah.
investors to reach out and say hi, like what would you want most from the
I would
audience?
say if you want to improve your focus, memory, impulse control, go to our website, sign up to our beta, and reach out.
Hell yeah. Thank you
Yeah.
so much for coming in.
Thanks. Thank you so much. It's been really fun.